165,000 apps in the Windows Phone store today. How can you make your app stand out? Good morning, everyone. My name is Stefan Wick, QA manager on the Windows Phone team. I really appreciate you guys all coming today to my session to hear about best practices for Windows Phone development. Over the last couple of months, I had a chance to work with a number of partners on bringing their Windows Phone applications into the Windows Phone 8 store. Today, I want to share some of the best practices, tips and tricks, and lessons learned with you. Before I get started, I want to let you know that I will give away a Nokia 925 at the end of this session. At the end of the session, I will ask a question about the content of my presentation, and the first one who gets it right will receive this phone. So please pay attention. So this is what it's all about today. We will talk about performance, making a good app great. Users have high expectations in your app's performance because they will compare the performance with the first-party experience that they see on the Windows Phone, and they will compare it with some of the top apps that they love and use every day that they've downloaded from our store. Quality. This is about finding the bugs in your code before you submit to the store. If you release your app with broken functionality, almost certainly your ratings and reviews will go down. Reach. Make your app available and attractive to a worldwide audience, and make it work on as many device types as possible. So let me dive right into performance here. There are two key areas I want to focus on. One is memory, in particular around images. The other is execution performance, in particular around scrolling large contents of data. I want to make this as practical as possible for you guys, so I will switch over to Visual Studio and spend most of my time there in actual code, showing you some of the common things to avoid, some of the easy things you can do to improve your performance, and I will show you how the Windows Phone 8 SDK tools can help you with all that. So with that, I will switch right into my first demo. And for my demos, I picked a very simple application. It's a sample that we actually shipped a long time ago for Windows Phone 7. It's kind of the hello world of a weather forecast application. And since it was developed for Windows Phone 7, there's a lot of opportunity to improve it from a performance and functionality perspective, taking advantage of all the great new things that we have included in the Windows Phone 8 operating system and SDK. So this is the app I want to look at, actually a different version of it. Just to remember, we want to focus on the memory usage as well as on the scrolling performance, because that's kind of where I've received feedback from my users. That's where some of the problems are, so I want to see how I can improve that. So first thing I want to do is, just to kind of get an initial idea of my quality, is I will do an app analysis for my little application here. So this will just run my app with some very lightweight, very simple profiling tools and gather some initial data on how my app is doing. And so I will kick this off, and this will launch in my emulator. So now I will go through my normal workflow scenario. So I will pick my favorite city, and I'll wait for the forecast to come in from the server, hopefully soon. And so now I can scroll through my forecast and scroll back. So this is my test scenario. I will complete this now and wait for the profiling tool to finish. So this sort of high-level basic profiling is also now part of the store test kit. So you should run it at least once before you submit your app to see that there are no red flags that would prevent certification. But it's also useful to run it on more an ongoing basis to kind of monitor how your app is doing in some of your key scenarios. So since this is really more kind of a hello world app, there are no big red flags here or anything outrageous. I do want to put some emphasis on the memory usage here. So we want to make a mental note of this value because this is one of the things that we want to improve here. So let's take a look at the code here actually. So since we're looking at scrolling performance of our data, a good place to start is always the data template for our control. In this case, I'm using a list box, and here's my data template. So the data template basically is the markup that describes for your data coming in, how should the runtime present the data to the user, how should the UI elements be created and laid out. So this gets instantiated for each of your data items as the user scrolls through the list, and so you want to make sure you optimize this part as much as possible, because anything you can save here has quite a bit of a multiplying effect to the overall performance. So the data template here is really simple, nothing too spectacular. I have a couple of text blocks for the different parts of the forecast, and then have an image here that displays a symbol for the type of weather that we're dealing with. So I want to take a closer look at this one. So this is an image that I'm scaling to 64 by 64 pixels, regardless of what the source is. So I will always display it at that size. So there's a great optimization I can do here, because since I get the images from the server that I don't control, they might be of different sizes. They might be significantly larger. So I don't want to pay that cost for decoding and creating large images if I really only ever display them in a small size. So here's simple optimization I can do. I can tell my bitmap to only decode at the maximum of 64 by 64 pixels. So now when I go back and run my analysis again with this change applied, so I'll select my favorite city. And so I can scroll through my content again, try to reproduce the exact scenario I was running before. And so now when I look at the results, I will see in my maximum memory a significant improvement. I started at over 20 megabytes, now I'm down to 17. So that is a good 20 to 25% gain with just a simple change. So going back to my code, ideally what you would do if you control the image assets, you would start with the right assets to begin with and not use larger than you actually need. But in many real-world scenarios, you are consuming feeds from the web that you don't control. The images may be a little bit larger or significantly larger than what you really need. And so decoding them to the right size actually helps a lot. So let me also show you what actually happens here and what you kind of lose by doing this optimization. So these are the two images. Again, one was the old setting, one was the new. And so they look pretty much identical, but as I zoom in, I see like the new version that I'm using now is much less granular when I zoom in. But since I only ever look at them at this size, I'm fine with losing that granularity, and no user will ever notice. Okay, going back to the data template. So another optimization we can do here around the image is the fact that keeping in mind that these images are always created on the UI thread when new data comes in. We instantiate these data templates. Spending all the time to create the bitmap and decode the image may not be something that we want to do while the user is scrolling on the UI thread. So we have a new option that we have added in Windows Phone 8, and that is the background creation option that you can apply here. With that, the creation will happen asynchronously here, and your interactivity in your list will improve dramatically, especially when you have larger images. For these small ones, you might not notice too big of a difference, but for large images, you definitely want to do this. This way, your data templates will be created very quickly, and then the images might pop in asynchronously from that. So one last change I want to do here to really optimize my image creation here. So I want to look at the URI source property here. I'm binding this to the weather type in my data object. So the weather type says something like sunny or rainy, stuff like that. And so then in order to determine what symbol I should download from the service, I have a converter that basically does the mapping on the fly. So whenever I scroll a new item into my view, I'll ask the converter, hey, what URI should I use here? So this seems like work also that we don't want to do, while the user is scrolling and affecting his or her interactivity. So I will just get rid of this converter here. And instead, what I will do, I'll bind to a different property that I have already prepared on my model that already has the mapping and conversion done ahead of time. So when I download the data from the server, I write a little bit of extra code to upfront do all the conversion that I need, and then my binding will be much faster during the actual execution. So I have a different property called condition icon, and that already has the right URI. So I'll save the extra cost for the converter here because I pay that cost up front. So that's about the image. There's one more important optimization that I should really do here. Since this is a sample from the 7 days, it still uses the old trusty listbox control, which was the way to go in the 7 days. In Windows Phone 8, we have added the long list selector to the core runtime, and this is now our recommended way to doing lists. It's basically a superset of the listbox control. It provides you with more smooth, more performance scrolling right out of the box, and it also has a lot of additional features that you basically get for free that I will show in a minute as well. So for now, I will just replace listbox with long list selector, and now I can run my app again just to make sure everything still works. Okay, so now everything works. My performance is much better, and I'm set up for the future with my long list selector, and I can add additional features to that. I do want to point out that for any sort of real scientific performance analysis, you want to do it on your actual device and not like I'm doing here for demo purposes in the emulator. But for relative performance measurements, like saving some memory and things like that, doing that in the emulator is actually totally fine. So I want to show, since I moved to long list selector, I want to show 2 or 3 of the most important features from long list selector that you get for free. So for that, I have a different feature that I've added to my weather app here, and that shows the history of my weather for the given location. So this is a very simple list where I really just bind the weather type and the date to my list, and then everything else, all the other magic in the UI is done by the long list selector control. So I get the grouping for free, so it groups it by months for me. I get the sticky headers here. You see how the headers for the months stick until I get to the next month, then they move down and the next one sticks. I get that for free. And I get the jump list behavior for free. So if I want to scroll all the way back to 2010, I can go to my jump list and then pick the months that I'm interested in from way back and scroll quickly up there. So all of that basically comes for free with the long list selector, and I can show you that in code real quick as well. Here's my history XAML, and so here's my long list selector. And my data template is really super simple here. I just have an image for the weather type and a text block for the day in the month. And you see here, I did the mistake again. I have a converter here that is completely unnecessary, so I can easily get rid of it by just putting the day actually in my data model instead of pulling it out from the timestamp as the user scrolls. So that would be an optimization to make here as well. But now all the other features really come from the long list selector for free. And I just set a couple of properties here on the control to make this happen. So I enable grouping, so I get the kind of month view, and I use a layout mode grid, so they get arranged in that way. I can specify my grid cell size, and I can specify how my group headers are supposed to look with a group header template. And then I can supply a style for my jump list, and that's pretty much it. And your history list is done. Okay, so that's long list selector. So now I want to move on to something else. I want to actually add another cool feature to my weather app. One of the key features in Windows Phone are the live tiles, and with Windows Phone 8 we have a variety of ways for a developer to use live tiles in their application. We have white tiles, and we can cycle through different ones and so on. So for my weather app, I want the user to be able to create secondary tiles for all the cities that they are tracking. So they can see on the start screen always the weather for all the cities that they're interested in. And I want to have a background agent that periodically gets the data from the service and updates the live tiles, so I always have fresh information. So in order to do that, it's actually a relatively memory-intensive operation that I need to run to create all these tiles in various different sizes for multiple locations in one execution of a background agent. That's especially tricky because in the background agent, the memory cap for your code is 11 megabytes. So the working set for that agent must not exceed 11 megabytes. If you go above it, you will get shut down. So let me see how can we do it. And I will show you my first attempt, and I've moved the code here into the foreground app, so it's a little bit easier to demonstrate and easier to debug as well. So I have my little magic button here that creates the white tiles for 4 cities here that I'm interested in. And so I'm measuring the memory consumption. And what I find is that by doing this, I actually increase the peak of my working set by 14 megabytes. So that's kind of a problem. When our budget is 11 megabytes, we will not fit that into the background agent. So let me see what we can do here, or what is the cause of this peak of memory. So the memory got released right after that, but it peaked up to that high of a value. So let me go into my tile page here and take a look at the code for my first attempt here. So I'm calling this function create tiles that creates these 4 tiles. And so what I find is the more tiles I create, the larger my peak gets. So there's a bit of a problem here. And so for each image, basically what I do is I create a writable bitmap, and then I have my logic all encapsulated in this function, where I basically parse the weather data, and depending on what the weather is like, what the temperature is like, I will put different background images, different symbols, different numbers on my bitmap, and then I save it to isolated storage so that the tile can pick it up. So nothing real fancy special here, but the thing to understand here and to realize is how the memory management works with the runtime in this particular scenario. because in order to render all our XAML elements onto this bitmap, our runtime, the native components, they take a reference on the writable bitmap here, and so those native objects, they will release the reference right away as soon as the execution returns back to the system. So basically, as soon as I'm done with this function up here with my create tiles. But as long as I'm still keep adding new tiles and executing in my user code, these relatively big objects for writable bitmap will not become eligible for garbage collection just yet. So even if you force garbage collection, it will still stay around. So that's something to be aware of. You can easily work around it by basically telling the system to run these function calls on your behalf. So I've created a little helper that basically uses the dispatcher to just tell them, run this function. When you're done, run the next function, and so on. So this way, the system always gets a chance to actually process and release the references before we do the next memory-intensive operation. So let me run with this change. Hit my magic button. And so now my peak is around 6 megabytes, so that will comfortably fit into my 11 megabyte budget. And more importantly, it will not increase the more tiles I add. So I can add more cities to my list and create more tiles for that, and the memory will stay around that value, will not peak above that. So I have one more thing to show in this demo, and so this is another important tip that we found to be very successful to identify problems with redraw in our UI. So there is a debug setting that's already in your code. If you've ever started a Windows Phone application, it's part of the template, but you have to enable, no, not this one, this one. You have to enable it. It's the enable redraw region setting. So let me start the application, and then I will explain a little bit what it does. So it adds a lot of interesting colors to your UI, but what the colors indicate, so whenever we rasterize and redraw a region on the screen, we change the color of it in this debug mode. So now what we see here is that quite frequently, actually whenever our busy ad control puts in a new ad, somehow we decide to re-rasterize and redraw the entire screen. So this is an expensive operation. It will use a lot of CPU. It will use a lot of battery, and your users will not be happy about that. So this is with this debug mode, it's easy to detect problems like these. So I recommend turning it on once in a while, run through your scenarios, and then watch out for things like that. So if I go, let's say, to a different view here, I can see in this view I don't have a problem. Actually, I'm not redrawing anything. Even when I scroll through this, things are not being redrawn. They're actually being handled properly by the GPU here. I don't re-rasterize stuff as I scroll. But this view clearly has a problem. So let me take a look at that XAML and see how we can fix it. So there is an easy cure for this. So I can tell the rendering system to treat special regions or special UI elements as their own rendering nodes. This way, I will make sure they don't get lumped together with the rest of my UI and cause a redraw in other regions. So here, I can set the cache mode, set it to bitmap cache, which ensures my ad control in this case will be redrawn separately by itself. So this is not to say that every ad control has this kind of problem. It depends on how you've structured your layout, and probably in 95% of the cases you will be fine and you don't see this problem. But chances are, if you have custom layout or you mess with the indexes and things like that, that you can get yourself into this situation where the system maybe isn't quite sure what it needs to redraw, and then it errors on the side of drawing more than it should. But with the cache mode property, you can then fix it and optimize it, because you are in the best position to know kind of what needs to be redrawn here. So now with this fix, I can see my add control gets redrawn, but the rest of the UI stays as is. The color doesn't change. So that's that. Let me switch back to PowerPoint real quick. So this was a lot of information in a couple of demos, so I want to take a minute to recap this. So we've seen a few new APIs that we've introduced in Windows Phone 8 SDK that can help you solve some of these memory and performance problems, specifically the decode pixel width and height, the background creation for bitmap images, and moving from list box to long list selector is another big move for you. In terms of best practices, as always, use appropriate image assets if you control them. Size them so that they are not larger than what you actually display. If you don't control them, then use decode pixel width and height. Also reduce the usage of converters to keep interactivity smooth. You could even take that to the next level and say reduce your usage of data binding if you have an option to reduce the number of bindings in your data template. Definitely something to consider as well. Test the redraw regions. Very easy test. Just enable the debug mode and then walk through your UI and see what you find. And then last but not least, reduce your peak memory by avoiding tight resource-intensive loops. So now I want to move on to quality. So how can you find all your bugs before submitting your app to the store? Short answer is create a test plan. We've actually published a kind of generic app test plan on the Windows Phone developer blog a couple of weeks ago. It's a 3-part blog post. If you haven't seen it, check it out. Has a lot of good information. You can use it as a starting point for your own test plan and adjust it accordingly. One of the key things to consider here is really understand the configurations that you need to test on. Just having the right set of test cases is great, but if you don't execute it on all the relevant configurations, you might miss out some important bugs that maybe only repro on non-English systems, or your app doesn't work on low memory devices, or your app doesn't render properly in the Light theme. It's actually quite easy to work this into your general workflow. So one thing I do typically when I develop and test an app, so I have my development phone. It's a 1 GB English dark theme phone. So with that in mind, I go ahead and configure my emulator to the exact opposite. So I use the 512 megabyte emulator. I set it to the Light theme, and I switch it to a non-English language. So, and then in my workflow, I just alternate between the two environments when I test out my code, and this way I kind of automatically cover a lot of configurations. And so actually now with Windows Phone 8 SDK, you can run multiple instances of the emulator simultaneously. So with that, you could even take it further and set up another emulator with yet another configuration and get some more coverage there as well. Also want to highlight beta testing. So the Windows Phone Store now supports beta apps. So before you submit your apps for good, submit it as a beta, and this way you can distribute it to a set of friends or coworkers who can then help you test it out. So this gives you kind of a safe environment to get some more real-world testing on different device types and so on. So last but not least, I want to talk a little bit about unit testing. I'm really excited about the fact that unit testing for phone is now integrated into Visual Studio, starting with Update 2, which released a couple of months ago. And So with that, you can now write phone unit tests, and it's fully integrated into the IDE. You can take advantage of all the existing Visual Studio unit test features around test case management, test result management, and so on and so forth. So that's a big step. Last year at Build, I was also talking a little bit about unit testing, and that was we were still kind of using the toolkit version of the framework, so it was kind of more painful to get your results out of that and all that. But now it's all just baked into the Visual Studio tools. So it's a big step forward. We now also have support for native unit tests for phone, in addition to managed unit tests. And it's important to point out that the unit test environment actually executes on the actual phone device or on the emulator, depending on your choice. So it's not running in some artificial isolated environment. So this is good to know, and this might also help you cover more of your configurations by just running your automated unit tests on like different languages and different configurations. So I want to switch back to Visual Studio now and demonstrate a little bit the new unit test support that we have in Visual Studio. So I'll use the same project here for my little weather app, and now what I want to do is add a unit test to it. So let me first stop debugging, and so now I can add a new project here. And so if you have Visual Studio 2012 Update 2 or later, you will find a new project type here that is Windows Phone Unit Test App. So I'll add this here, and what it does is essentially creates a new phone app in your solution that is integrated with the unit test environment in the IDE. So let me bring up the Test Explorer here, and so here's kind of a dummy test case that it creates. And before I start, I have to tell it kind of what I'm actually testing. So I have to add a reference to the project that is the subject of my testing. So let me also add this here. And so now I can go ahead and write unit tests for my weather app and its components. Since you don't want to see me typing, I should have something here on the toolbox that I can drag in. So what I have here is a very simple unit test for my city object. So I instantiate a new city object, and then I verify that all the properties are as expected. So let me run this real quick. And so as you see, it will actually run on my emulator, and I have the result here. And so now to kind of drive the point home that I made earlier, that unit testing can help you cover some of your configurations. So let me try deploy it on my other emulator here. So this guy, so this one I've set up to run as a German operating system, and so now I run my my unit test on this one. And so obviously there's a problem. And so what I see here is I'm trying to parse the latitude and longitude values that the test passed in. But since not all languages use the point as a decimal separator, these strings can't be passed on a German OS. And as a matter of fact, my app is indeed broken on German. So if I try to run my real app here, it will actually crash on startup because of that exact same problem. So this is to kind of really highlight that it's important to test on these configurations, because otherwise you will get a lot of bad reviews from all your customers in countries that use a different decimal separator than the point. So the fix is easy. When I pass this, I need to tell it kind of what culture the data is in, so the system can parse it correctly. So, oops, making this fix here. So now let me rerun my unit test, and so it passes. And also let me redeploy my app and see if it now works on my German configuration. Now it comes up, it works fine, at least so far. So now when I drill further in, now I see, oh, I have the next set of problems. Good thing I test in the light theme, because this forecast is not very readable. The light blue is hard to read, and then the forecast, white on white is even harder to read. So it turns out in this case I've hard coded the font colors, which doesn't work very well with themes. So instead, we should be using the themed resources so we can adjust appropriately. And yeah, so this one I didn't even make up. So that is actually how that sample originally shipped. So let me show you one more thing with unit testing. So this was kind of the basics, how to get started. I have another project here to kind of show a few more things that you can do if you want to take it to maybe a little bit of a next level. So here I have a very simple game. So don't even pay attention. It's kind of a Hello World application. It's a trivia game with questions. I can select an answer and get the feedback, and then I can pick different questions. So, but what I wanted to do here is write some unit tests for my user control here, because this user control has pretty much all my logic. That's basically my entire app, and I want to make sure I have good unit tests and regression coverage on that. So for that, I've already created a few test cases here. I want to run through them real quick. And so I've added some sleeps as well, so you can actually kind of see what happens. Otherwise, it would just be done within a fraction of a second. So what I've done here is I've taken advantage of the fact that the unit tests actually run on the phone, so I can actually put my user control into that application and put it under test and poke at it and verify certain things. So with that, I was able to verify a lot of pieces, not only from the logic but also from the UI itself, to make sure the bindings are set up correctly and they work well. So all my tests actually pass here, except for one. We'll look at that in a second. Just wanted to look at one of these test cases real quick to kind of give you an idea of what I'm doing here. First, I have an initialize method that I run before all the tests execute, and for that, I load the control into my UI. So this I execute once, and then the test methods I will execute on that same instance of the control. And what I'm doing here is basically I set a data context to a new type of question and select an answer, and then ultimately I verify that the right things have happened in my control. The one thing to note here is in the new unit tests in Visual Studio, unlike the previous Toolkit unit test framework, the execution happens on a dedicated thread, so it doesn't happen on the UI thread. So if you have tests that do interact with the UI, you have to make sure you marshal the execution over to the UI thread. And so I'm using a little helper here that does that, but basically this is just a dispatcher begin invoke call to get the execution on the right thread to make that happen. And so now let's look at the one case that failed here. So this is a very simple test. Again, I'm loading my control into the UI, and then in my test method, all I'm doing is I remove the control, I force garbage collection, and then I expect that that the weak reference that I took on this control is no longer alive, meaning it has been garbage collected, there's no leak. So that's my expectation. But obviously this one fails here, so this is a problem. I'm highlighting this one because I think it's a good practice, especially since we're talking so much about memory and supporting low memory devices. So you want to make sure you do your part, and you don't have object lifetime issues in your component. So this is an easy way. If you write tests like these from the get-go, you can detect easily once a change in your control maybe causes an object lifetime issue in your app. And if you have a control leaking like this, can actually be pretty severe for your application, because your control keeps a reference to its parent in the tree, and with that, essentially your entire page will leak. And depending on what's on the page, it could be megabytes worth of data that are gone per iteration. So let me go ahead and fix this bug real quick. So in my control, the root cause of the bug is kind of a typical canonical example. I have registered an event to on a static class, and I never bothered to cleaning that up. So this way the event handler basically lives for the duration of my application and keeps my control alive. So what I need to do to fix it is when my control unloads, I have to unregister from the static event. And so now when I rerun my test, so now it passes, no more leaks, and my memory is happy. Okay, I think with this I'm going back to my deck. Moving on, we want to talk about reach, making your app available and attractive to a large audience of users and on as many devices as possible. One important thing to note is that currently the 512 megabyte devices are kind of the fastest growing segment with all the Windows Phone devices out there. So you want to make sure that your app really runs great on 512 megabyte. That's also why we made the default in Visual Studio for the emulator. If you hit F5 the first time, what we launch is the 512 megabyte emulator. For that, it's really critical that you monitor and optimize your memory usage. We already talked about that a little bit, but I can't emphasize this enough. There was another talk. It was already yesterday, but you can, of course, still watch the recording from Andrew Whitechapel. So he had a dedicated talk about low memory devices and other hardware constraints. So I highly recommend you checking out that talk as well. So he goes into a lot of details around the memory caps, what all the different caps are, why they are that way, and how you can make sure your app runs great with all these caps. So I want to move on and talk a little bit more about international, actually. So with Windows Phone 8, we now support over 200 markets with the Windows Phone Store. And in the Windows Phone UI, we support 50 different display languages. So now when you write your app, you want to consider definitely at least making sure you can run on a globalized variety of devices. We've already seen that in one of the tests here, where runs fine on English but fails on German and a variety of other languages. So testing for that will help you a lot, even if you don't plan to actually translate your UI or adapt your content for other markets. Now, to really maximize your reach on a global scale, you do want to look into localization and see if you can translate some of your UI for some of the markets and languages that you want to target. And with the tooling support that we now have in Windows Phone 8 SDK, it's actually easier than ever, especially now with the multilingual app toolkit that I will demonstrate in just a second. So this is an additional tool that you can download. The link is on my resource slide. It integrates nicely into your Visual Studio development environment, and it also integrates with the Microsoft Translator to really make localization very easy for you. So let me show you that demo. So I'm back to my weather app here. So this is, actually let me start it real quick. So this is the English version of my weather app. I have no data in the app right now to just kind of highlight the UI pieces that I develop and I own in the app. So there's a couple of strings here in my app bar and in my UI. And so now I want to go ahead and localize these for a different language. So first thing I want to do is for my project is enable. Oops. Oh, I have to stop the debugger. Go to Tools and enable the multilingual app toolkit. So I've already installed the app toolkit on my machine. Version 2 has released just this week, so it's brand new version out there with a lot of new features. So I will enable the toolkit for my project. What's happening now behind the scenes is some changes some additions are made to my project. And one thing I want to highlight here is I'm not sure why it's not opening. Okay, it should open in a different editor. Something got messed up here. Let me see if I can launch this again. So here we are again. Okay, I'm not quite sure what happened here. So there's supposed to be another editor coming up. Somehow that association got screwed up here. But what it does is it creates a new XLF file here in my project. It's an industry standard XLF. It stands for XML localization interchange file format. It's a common thing to interchange with localization vendors, so you can send in your strings to a vendor. They localize it. They don't need to have your development environment or your code or anything. They can send it back, and then you can integrate it into your code again. So by default, what it does, it creates one of these for the language that we call a pseudolog. So this is not a real language. It's a pseudo language, and so I can use this to localize my strings, and hopefully that works. Yes, it does. So as you can see now, my strings have been changed here. In the app bar and in my client area, they have been localized with kind of random strings. So how is this helpful? What do we get from this? It's actually pretty useful, because now I can easily see what are actually all the strings in my UI that I have set up correctly for localization versus strings that maybe I've missed, that I have hard-coded, and that are not set up for localization. So I see the title here, Windows Phone SDK sample. This is not being localized. because I didn't set it up for it. In this case, that's actually intentional because that's kind of my brand name. I don't want to localize it. Everything else I do want to localize, so now I can see correctly it gets picked up by the tool and gets localized. The other thing that you can get from pseudo localization is finding problems in your layout. Maybe if your string size changes due to localization, maybe your layout gets screwed up and your app doesn't look right anymore. And so you can catch this here as well. Moreover, you can find some font problems if maybe you are using a special font that doesn't support international characters. You can catch it here as well because the pseudo localization focuses on injecting as many kind of international special characters into your strings. So it's pretty useful to test kind of the localizability of your application. So now let me see if I can actually get a real localization going here. So let me stop the debugging. Now I want to add a translation language. So this pops up a dialog. It's a long list of languages here that I can choose from. As you see in the list, we highlight which of these languages is actually supported by the Microsoft Translator Service. So I want to pick one of those that is supported. And so I will pick German, since that's the language I know. And so now I get another XLF file here now for German. And so with that, I can also try to generate my translations. And so let me see if I launch it in my German emulator, what happens. So now I have my app localized to German correctly, and I can actually vouch for these strings are correct. So what happened here behind the scenes when I click generate machine translation, we connect to the Microsoft Translator Service in the cloud. We send up our strings from the English project, and the translation service translates them on the fly into German, sends them back, and integrates them into the project. So next time I hit F5 and run on my German machine, my app is in German. So this is a really easy way to get going with localization. I don't think it gets much easier than this. And so this is a great way to start for you guys to kind of get a much broader reach on a worldwide scale. Okay, going back to my slides. Next topic, in terms of reach, I want to talk a little bit about versions, OS versions and app versions. So Windows Phone 8 SDK has a lot to offer in terms of new features and new functionality, new performance improvement and all that. So if you build an app today, you definitely want to target that. Or if you have an existing 7 app, you want to target that version by upgrading your app to get the best user experience for your customers. However, to really maximize your reach, you also want to maintain your 7.1 application still, because there's a lot of users out there who still run their Windows Phone 7 phone, and you want to reach them as well. You want to provide them with updates and so on and so forth. So for doing that, I think it's really important that you think about a strategy for sharing your code between those two versions of your app, because just kind of completely forking your code and then maintaining 2 or more versions is not something that scales really well. So there are a couple of great options for you to do that. First option I want to highlight is you can have one app project that basically just has 2 different configurations. So you can choose to build for 8.0 or choose to build for 7.1. So this is useful in cases where maybe the differences are really, really small, and you just have maybe a handful of if-def statements where you highlight some new 8.0 functionality, but the rest of your app is pretty much identical. In the second option, there you have two app projects with shared libraries. So this is a scenario where maybe you say, hey, for 8.0, I really want to redesign my UI and want to create a whole new set of views. And I only want to reuse my business logic. And so that's what you put in the shared libraries. And then everything else is sort of separate, and you maintain it separately. And the last option is kind of my preferred option, because I think it's the most flexible and also kind of the cleanest from an engineering perspective. And this is really using source control in TFS to create two branches of the same project. And so then you upgrade one of them to 8.0 while keeping the other on 7.1. But all the files in these projects still have a direct relationship to each other. So what you then will do is, by default, do all your development in the 7.1 branch and merge the changes into 8.0. And only for the 8.0 specific features that you want to highlight, you do them directly in the 8.0 project, and that's where they stay. They never go into the 7.1 project. So that's a very flexible approach. TFS makes it really easy, and if you are one man or few man project, you can even use TFS Express for that and set it up like that. So we're almost out of time, so I will skip over kind of the code sharing demo, which is mostly around showing the TFS scenario. In the interest of time, I want to start kind of recapping what we've done today to our little weather app, how we've moved it forward. So we have significantly improved our memory and our scrolling performance. We have created unit tests for regression control. Our app is now ready for mid-tier devices, devices with lower memory. And our app is ready for the world. We have actually localized it. We've tested it on various locales. And we're ready for Windows Phone 8. We have our Windows Phone 8 version while still maintaining our existing Windows Phone 7.1 version for maximum reach. So before we close, I want to remind folks to fill out evaluations, and so for the end, I hope you've learned something useful in this talk. I really appreciate you guys' time for coming, and hopefully by applying all the techniques and tips and tricks and best practices, you will be able to get a lot of 4 stars and 5 stars reviews on your apps going forward. Before we close, I will ask the question for the Nokia Lumia 925. How many display languages does... Can you come later, and then we'll exchange the phone. All right, that's the end of my talk. A couple of resources here. Thank you very much.